Day 131, Physics Electrostatics Homework number 5. And here we have 3 collinear charges in which we will be applying Coulomb's law, which is F equals K Q sub 1 Q sub 2 divided by the distance squared. We'll be applying that relationship to each pair of charges at a time. For example, looking at the diagram over here on the right, I've redrawn it. Let's look at the -4 microcoulomb and a 5 microcoulomb charge. They're attracting each other. And I could draw that with a diagram like this. This would represent the pair of forces. Let's call it F sub 1 and F sub 2, but they're equal to each other according to Newton's third law. They attract each other. And we can calculate, I should call that F sub, we call it F sub 2, not F sub 3. So F sub 1 and F sub 2. So they're attracting each other. And I'm going to calculate those two forces, F sub 1 and F sub 2. So F sub 1 equals F sub 2 equals, I'm going to plug in 9 Coulomb's constant, 9 times 10 to the 9th, times charge number 1. And we don't need to put the negative in there because that's already taken care of with the direction of the arrows already in the diagram. So 4 micro, and remember micro is going to be times 10 to the -6, times the 5 micro. Remembering to put that in your calculator is times 10 to the -6, divided by how far apart they are, which is 0.12 meters, 12 centimeters squared. So if you do the math there, that comes out to be 12.5 newtons, which I've done ahead of time. So they're attracting each other with that force. F1 and F2 are both that magnitude. All right, now let's look at the last two, the 5 and the 6 microcoulomb charge. So we're going to ignore the -4 for the time being. I'll use a different color. The 5 and the 6 repel each other. So I can show that by, let's call this F sub 3, F sub 4. They repel each other because they are like charges. They're both positive. And I can calculate F sub 3 and F sub 4. And once again, it's Coulomb's constant, 9 times 10 to the 9th, times 5 microcoulombs, times 6 microcoulombs, divided by their distance, which is 0.09 meters squared. That gives me a force of 33.3 newtons. They're closer together and they're larger charges, so we have a larger force there. That's 33.3 newtons. There's a decimal point there. Let me see if I can make it bigger. That's the decimal point, 33.3 newtons. All right, then we have the outer two charges, ignoring the 5 microcoulombs in the middle, the 4 and the 6 microcoulomb charges. They are attracting each other. So I will denote that as F sub 5 and F sub 6. That's going to be a weak force because they're far apart, but they're equal to each other. So F sub 5, which is equal to F sub 6, so it's just the same thing, 9 times 10 to the 9th, times the 4 microcoulombs, times the 6 microcoulombs. Now watch the distance here. The total distance from the -4 to the 6, the 12 plus 9 centimeters gives me 21 centimeters, which is 0.21 meters squared. I plugged it all in my calculator, and I have 4.9 newtons. Okay, so what I need to do here in this problem is I need to find the net force. Let's try yellow. I don't use yellow a whole lot. Let's see if that shows up. All right, in part A, I need to find the net force on the -4 microcoulomb charge. And when I look at the diagram, I see in a diagram that over here for the -4 microcoulomb charge, it has 2 applied forces, F sub 1 and F sub 5. So I need to look for those, and they're in the same direction, so it's just simple addition. F1 is the 12.5 newtons, and the F sub 5 is 4.9. So bottom line is I will be adding those two to get the F net on, so F net for that one, F net equals F sub 1, which is 12.5 newtons, plus the, what do we say, 4.9 newtons. Not a big fan of the yellow, but okay, F net on the 4 microcoulomb charge then is 17.4 newtons. And that is to the right. So that's my answer for the net force on that charge. Part B, I'll switch to a different color. Part B, I'm going to run out of space here probably. F net for the 5 microcoulomb charge. All right, I look in a diagram, and I see on the diagram that it's the force 2 and force 3. They're both directed towards the left, so the answer will be towards the left, but I look up those two. F2 is 12.5, F3 is 33.3, so F net will be the 12.5 plus the 33.3. So F net equals 45.8. Oops, 45.8 newtons to the left, because both those vector arrows are pointing to the left. All right, I have one more here. Let's see if this will all slide up. Yeah, well, I'll slide up just a little bit so I can squeeze it in here. All right, part C. And we'll choose, well, I'll go back to red. All right, so for part C, F net for the 6 microcoulomb charge. So F net will be the 2 forces applied. Now, be careful here because I see that F sub 4 is to the right and F sub 6 is to the left, but which one's greater? Let's see, F sub 4 is the greater force. So I want to take the bigger force minus the smaller force. F sub 4 is much bigger. It's 33.3 newtons. So I'll go back to, well, down here. So it's 33.3 newtons minus the F sub 6, 4.9 newtons. So F net for that 6 microcoulomb charge, that's what, 28.4 newtons? And the direction will be to the right with a stronger force. F sub 4 is bigger than F sub 6, so that's towards the right in this diagram. So there's my net force on that last charge. Congratulations. This problem's done.